refraction and thin lenses. This is the topic in IGCSE Cambridge Physics 0625. So we are going to have a candid discussion on how you're supposed to answer different questions as far as this topic is concerned. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. In order to access our papers and this document you can see I'm having here, you can be able to join our Patreon page, whereby you can be able to download all these documents that I'm displaying at this particular point. Without much ado, let's just dive in so that we can be able to see the kind of question that have been asked in years before in this particular topic of refraction of light and also thin lenses. In this particular question, we are supposed to draw two rays from the top of the object incident. There are two rays from the top of object incident to the lens as shown on the diagrams. And then on the diagram, continue the path of these two rays to show the position of the image for this particular object. So now here we have the object. The diagram is a full-size ray diagram showing the formation of image by thin lens. Then circle items in which they describe the nature of the image formed. So we are having the object and then we have the image here, so which means that we can be able to pick a few things about this particular image that we are having here. So what we need to realize that this image is upside down compared with the object here, so which will mean that we are going to say the image is inverted because it's upside down. And also something else we need to notice here, the image is bigger than the object, then we can be able to say the image is basically enlarged. That's what we are going to say there. Then we are going to say the image is real because it's formed by real rays. We are not, because the image is formed by real rays. So that is something that you are to remember. State one feature of a visual image. One of the features we are going to say is that it cannot be casted, or it cannot be formed on the screen. Cannot be formed on the screen. At the same time, we can be able to say visual images are formed by imaginary rays. Formed by imaginary rays. So those are a few things that you can be able to remember in that case when we are talking about visual images. Moving on with the paper. Here they are asking determine the focal length. So the examiner was trying to check, do you understand where the focal length is? Because we know any ray that passes parallel to the principal axis is going to be refracted such that it passes through a point on the principal axis, and that's where we have the principal focus. So if we want to find the focal length, we're going to measure the distance from the center of the lens to where the F is, and this is going to give us 2 centimeters. This is going to give us 2.0 centimeters, 2.0 centimeters in that case. Now, we are also given another question here, whereby we are told on the diagram make label, mark and label F, which is a point where we have the focus. But we are told that the lens has a focal length of 3 centimeters. So we know that the one box represents 1 centimeter. So meaning this 1 centimeter, 2 centimeters, 3 centimeters. So we shall have our F at that point. And also here we shall count from this other side, 1, 2, 3. So our F also will be at that given point. So which means now that we have our focal principal focus, then we can be able to draw a ray and show the position of the image. So how do we do that? We are going to draw a line that is parallel to the principal axis from the top of the object like that. That is the first line. And this line that is parallel to the principal axis is going to be refracted such that it passes through F. So we are going to put like that, and then we are going to extend our line going like that, passing through the point F there. Another ray of light that is going to be used to locate the image is a ray of light that passes through the principal from the tip of the image through the center of the lens like that. But if you can notice what's happening here, these rays that we are having at these given points are diverging. So when these rays are diverging, it means there's a possibility that they are going to meet behind the mirror. So or this converging lens. So we are going to extrapolate that line backwards like that, and also this one we are going to extrapolate it that way so that we can be able to locate like that. Yeah, so you have to ensure you do it quite accurately, and you can see now they are going to meet at a given point here. So since the rays that have created this image that we are talking about here are broken or are virtual, then it means I'm going to have my image dotted because it's now a virtual image. State and explain whether I is real or virtual. This is virtual because it's formed using virtual rays or virtual rays or imaginary rays. Yeah, so that's basically what we are going to put into consideration when we are answering this. State the name given to the lens used in this way. You can see the object size is smaller than the image, so we can say this is magnifying. Lens. Magnifying lens. Yeah, so you can say it's a magnifying lens. So if you are new to Proflan, consider subscribing so that anytime we are going to do more tutorials, you'll be notified. And don't forget to check our Patreon page and also join there so that you can be able to download these papers that we are having at this given point. Now, without much ado, we can be able to continue to the next question and get to see how you were likely to have approached more of questions. Now, the focal length is 3.0. Rays of light parallel to XY are traveling towards the lens. So they are not really telling us which rays, but we can be able to say there is a ray traveling towards the lens like that, and there is another ray. We can be able to say anywhere. We can just locate it anywhere, but they are telling us just rays are traveling toward the lens like that. And a ray, when it's traveling, basically that ray is having an arrow that way. Then if they are parallel, then they are going to pass through the principal focus 3 centimeters. 1, 2, 3. 3 will be here. That will be the principal focus. So the first ray is going to pass through that point. After refraction, is going to pass that way, and the other ray also is going to pass through the same point because the two rays were parallel. So also this ray is going to pass the same way. So you can see the two rays are going to converge at their point, and that point they are converging is the principal focus. So describe what happens to the right after it passes through the lens. After they pass through the lens, they converge at the principal focus F, which is 3 centimeters from the lens, and also they converge at the principal focus. Again, they diverge from F, from that particular point that we've identified at this given point. So basically that is exactly what's going to happen there. And then you are asked to state the meaning of monochromatic light. What is the meaning of monochromatic light? This is light of a single frequency. This light of a single wavelength. Yeah, this is light of a single wavelength that we're going to have here. Now we have question 8, and we're told the diagram is a full-scale diagram showing converging lens. The two principal focuses F1 and F2 are indicated here. And then on the diagram, draw two rays. This is the object. So if that is the object, the first ray that is used to construct right for the ray diagram is going to be a line that is passing through from the tip, but that line runs parallel to the principal axis. That's the first line that you draw from the tip of the object, and then that line runs parallel to the principal axis to meet the lens, like that. And a line that is parallel to the principal axis is going to be refracted such that it's going to pass through the principal focus, like that. Then that ray is going to be refracted and it will go like that. And then another ray that runs from the tip of the object is going to pass through the center of the lens. And then this is going to be like this. Let's see. Going to run that way. Yeah, so what do you notice? The ray are diverging. This one is diverging, so the rays are actually moving away from each other. So the only option that we have here is just extrapolating the rays backwards. Yeah, so if you can look at this keenly, open your eyes widely, you will realize that the rays are going to appear as though they are meeting somewhere behind here. Yeah, you can see. Yeah, so they are meeting at a point here, and our image is going to be formed there. This is going to be our image. Yeah, so what are the characteristics of the image formed? Image length, we are going to measure this. This is around 2 point, this is 2 point, which value is that? Image length is around 2.7 centimeters. And then we are supposed to write the characteristics of this image that we have here. Number one, the image is bigger than the object, so this is magnified. The image is same sense of direction. Both of them are facing downward, so we can say same way up as the object. I know some students will make a mistake and say upside down compared. No, you can see this is facing down, also this is facing down. Yeah. Then also we are going to say the image is vertical because it's formed by imaginary rays or dotted rays, or vertical rays, and this image can never be casted on the screen, never be formed on the screen. So those are the key areas that you really have to remember as this is concerned. We are done with that. We have located the length of the image, and then we have stated the characteristics of this particular image. Moving to question number 9, also is a question that is commonly asked, and here we are told that the diagram shows rays a ray of light passing through an optical fiber, whereby we are told that optical fiber is made of glass that has a refractive index of 1.4. So we are given refractive index. No light refracts, so meaning total internal reflection takes place at point P and point Q. So we are supposed to calculate the minimum value of I. Yeah, so minimum value of I, what is this going to be equivalent to? So something that you need to remember is that sine of the critical angle is equals to 1 over the refractive index. This is the relationship that you really must have remembered in order to earn this mark. Yeah, so meaning for us to find C, we are going to say C is equals to sine inverse of 1 over 1.4. Yeah, so if you just put that in the calculator, let's put this in the calculator and get to see what it's going to give us. We shall say shift sine, because we are finding the angle, so we shall say shift sine 1 over 1.4, and if you work it out, you are going to get 45.5. so this is 45.6, which we can say approximately 46 degrees. Approximately 46 degrees will be marked correct. Yeah, so that's it. Describe and explain the action. Explain the action of the optical fiber in communication technology. And of course, what we need to put into consideration when we are talking about the optical fiber, actually optical fiber is just a thin glass, which is made of a dense glass inside here, but this glass is coated, the outer layer is coated by a material of low refractive index. Yeah, so this material that is coating here has a low refractive refractive index, but the glass inside is more denser. So which means when light moves like that, because it's traveling from a dense medium to a less dense medium, the outer part is a less dense medium, then because the angle of incidence is greater than the critical angle, then this ray is going to be undergoing total internal reflection. Upon striking here, again, this is the normal here, and we have a normal here. This is going to undergo total internal reflection at that point, and eventually the light is going to emerge out. So basically that's what happens in the process of data transmission. The outer layer of this particular glass is made of a less dense material, so that when light is moving from a dense medium, which is the glass, to a less dense medium, then there's a possibility of total internal reflection taking place. So how are we going to approach this particular question in the process of answering that? So describe the optical. So we are going to say light passes through glass and it undergoes total internal reflection, because light is moving from a dense medium to less dense medium, and angle of incidence is greater than the critical angle. So total internal reflection occurs, hence transmitting data, all information. So basically that's what we are going to write to the examiner for you to earn a whooping 3 marks. You earn a whooping 3 marks for you to just say that as light travel through the dense medium, the thick glass which is dense, upon hitting the boundary, it's going to undergo total internal reflection because the angle of incidence that we are having here, angle of incidence is greater than the critical angle at that given point. Number 11, and number 11 is also another question that basically was asked here. Let's get to see what we were supposed to do in order to earn all the marks. So here we are told that the diagram shows an object OB positioned 20 centimeters from the thin converging lens. Both principal focus are labeled F. Two rays from the tip of B are incident on the lens as shown on the diagram. On the diagram, continue the path of these two rays. We're supposed to continue the path of the two rays. So the first thing we can notice here is that this ray that is passing through F, upon reaching the lens, is going to be reflected parallel to the principal. It's going to be reflected parallel to the principal axis. It's going to be reflected like that. And this one is going to pass through the principal focus like that. Then we can see now, if you extend the ray backwards here, you are going to find the point of intersections where the two points are what? The two rays are meeting, and this is going now to give us our image for that case. Yeah, so draw an arrow to show the size, the size, the position or orientation of OB. So this is going to be upside down like that. It's going to be upside down there. So that's basically what you are supposed to do in that particular question for you to earn those marks in that case. All right, next part in question number 12, we are having here the image. Now things are getting tough because in this particular question here, we are now not given the object, we're given the image. How do you locate the object when you're given the image? So the first thing that you need to remember is that always there is a ray that runs from through the center of the lens. Always there is a ray that runs through the center of the lens, and that ray is always undeviated. So we are going to draw that ray that way, right? Next point, always there is a ray, yeah, there is a ray. Of course, are we located? What were we told the principal focus on each set? So we are told it was 5 centimeters. Yeah, the focal length is 5 centimeters. So we have to locate that. On the diagram, mark the principal focuses. So let's mark 5 centimeters. 1, 2, 3, 4, 5. So we shall have our F here. And also 1, 2, 3, 4, 5. We have also F there. So we can have our principal focus here, and we shall have our principal focus at that given point. Okay, so we have said there is a ray that basically run from parallel to the principal axis. There is a ray that usually run parallel to the principal axis. Upon hitting the lens, it's going to pass through the principal focus. So meaning that we're going to draw a line, yeah, and that ray always it's emanating from somewhere. Yeah, so we are going to say okay, all right, so it will be coming that way. So you are joining from the top of the image to F, so that you know where is that ray that is going to be refracted from the lens going to pass from. So you're going to join from this top to F, but don't draw a continuous line there. I'm going to show you exactly what to do, bro. So don't. You now join that ray from the, let me just here. Yeah, you can see this. Yeah, can you see that? Yeah, there's a ray that is passing from the lens through the principal focus. Then this line now from here, that ray is usually parallel to the principal axis, then it's refracted through F. So from this point we can now draw it this way, this ray, like that, like that, like that. Yeah, so the ray runs that way, passes through that. So the starting point is here, meaning now this is our object at that point. This is our object at that point, because you can see now this ray will be extrapolated backwards so that we can be able to locate where our image is. Now, using determine the distance of the object from the center, of the lens. Object from the center of the lens, let's measure that. That is 2.8, around 2.8. Explain total internal reflection. This is when light that is traveling from dense to less dense medium undergoes reflection without any refraction. This occurs when angle of incidence in the dense medium is greater than the critical angle. That's when total internal reflection will occur. So which means that you really ought to remember the conditions for total internal reflection. The ray of light must be traveling from a dense medium to a less dense medium, and also the critical angle must be greater than the angle of incidence must be greater than the critical angle there. Okay. On the diagram, draw part of each ray to locate the position of image formed. Of course, this first ray is going to pass undeviated that way. Yeah, undeviated like that. And this ray here is going to pass through F. Going to pass through the principal focus. Like that. Then the image formed is going to be upside down. Yeah, so that is where the image is going to be formed. Just a walk in the park. A walk in the park. Ring distances equal to the focal length. Focal length from C to A, or from C to B. C to A, SC, or CB, like that. Oh, this is the image. Okay, how do we get the object usually? One ray, a ray will run from here through the center of the lens there's a ray that is coming from the object through the center of the lens, is going to meet the image there. So that is it. It's going to go like that. That's one of the ray, right? There's the ray that's running through the center of the lens, and they are gonna meet somewhere here. There is also another ray that usually pass through the principal focus, and it's right from the lens. It passes through the principal focus like that. That ray will have, oh, my diagram, oh my god, this diagram, oh. Our B is here, so we have to be very careful, as if our life depends on this. Then this ray will be like that. Okay, so there is a ray that usually passes through the focal length, the principal focus, and they are going to meet with this other ray somewhere here. Now this ray that is going to pass through F usually is what? Parallel to the principal axis. So we shall draw this ray at this point parallel to the principal axis like that. So you can see that ray will pass like that, it will move this way, it will meet here. So where the two rays are, that's where the object should be. This is where our object should be here. This is where our object should be. The object will be there. Object will be there. Okay, all right. So okay, we are having two questions remaining. Here. Yeah, so this is our IGCSE Black Friday, IGCSE Black Friday, where we are going to be going through the concept that you must know for your main exam. So every Friday we shall be having IGCSE Black Friday Physics. So consider joining every Friday so that we can be able to demystify, and also to ensure that we simplify the physics concepts that are giving you a headache. Let's continue. Now on the diagram, it shows an empty container, and we have an observer with a red and black eye there. The observer and the coin stays in the same position when filled with water. So some water is going to be filled here. Let me assume that we are going to have some water here, and the container, the coin is going to remember wherever it was. This is some water that has been placed in this container. So we have some water here. Explain why the coin can be seen by the observer when it's filled with water. So it means light from the coin bends at the surface. Bends at the surface towards the eye. Yeah, so when light from this coin reaches the surface, it will bend, because light will be because light will be traveling from a dense to less dense medium. So it's going to travel at the boundary, it's going to bend away from the normal, because it's traveling from a dense medium, which is water, to a less dense medium, which is air. So at the top here we have air, and down here we have what? Water. So something that we need to realize, when a wave is moving from a medium, when a wave is moving from one medium to another, the speed of light is going to change. So if light is moving from a dense medium to a less dense medium, this light or this wave is going to speed up, and it will bend away from the normal. And that's exactly why this happens, because if we are having light traveling this way here, for instance, let's say light is going to travel from here to this point. It's going to travel that way. This is how light is going to travel from the coin, right? Then at this boundary here we have a normal. A normal is a line that makes 90 degrees. A normal is a line that makes 90 degrees with the surface. So this normal here makes 90 degrees with this surface, okay? So upon light reaching here, is going to speed up because moving from water which is dense, so it will speed up, and when light speeds up, it bends away from the normal. So this light is going to bend that way, okay? You can see that light is going to bend that way. If there is another instance where light is going to travel from the lens, from the coin to the normal, like to the surface like that, again this point here we shall be having I think I've drawn this not correctly. Let me just draw another one, ray moving that way. Then we shall have a normal here, yeah, ray moving like that. Then this as another normal, and again is going to bend like that. Then you can see now these rays that are bent like that, if we extrapolate, extend them backwards, they are going to meet somewhere, and this is now the position where the image of the coin will be seen. Yeah, the coin will be seen as though it's raised in a way. Yeah, so that is what we call apparent height. There will be some height, it will be down here. That's why sometimes when you are going to if you drop a coin in the swimming pool, you realize that when you look at that coin that is in the swimming pool, you feel like you see as though it's on the surface, but in the real sense is on the floor of the swimming pool. That happens because of refraction. Because it's formed by imaginary rays. These ones that I've tried to extend here is formed by imaginary rays. So we're supposed to say the name of the process that separates light. This is actually dispersion. Yeah, so we need to state that this is dispersion of light. Dispersion. State the color of light on the screen at point A. At point A we have violet, and at point B we have at point A we have violet. Oh, sorry, this one here, there's a question. State the color of light, shortest wavelength, that is going to be violet. One that has shortest wavelength is called violet. And what is the significance of this particular refraction? So this is going to be, so I'm making a mistake here. This is going, because we are having refraction taking place at A, the A is going to be red because it's going to be refracted least, and this is going to be violet because it's having a shortest wavelength. Shortest wavelength is going to be refracted the most. This is going to be refracted the least at that point. I think I was about to make a very dangerous mistake. State the property of the glass that causes white light to be split into different colors of the spectrum. So this is going to be the refractive index. All glass is denser, so refractive index. Yeah, so as light is going to pass through glass, is going to be refracted, or it's going to be bent because it has a larger refractive index. Speed of light in the block is that, calculate the refractive index. We know that the refractive index is speed of light in a vacuum divided by the speed of light in a material. So that's going to be 3 times 10 raised to power 8 divided by 1.9 times 10 raised to power 8. So if we work out this using our calculator, we are going to put in this, and then we're going to say this is going to be 3 times 10 raised to power 8 divided by 1.9 times 10 raised to power 8. This is going to reduce to 1.58, approximately 1.6. Approximately, you can say 1.6. And something that you ought to remember is that refractive index does not have any units, because this is a ratio, a ratio of speed, or a ratio of the sine of I over sine of R. So we don't have any units for refractive index.